Hello, everyone. I'm so glad to see all of you here today. And at the beginning of my talk, I would like to introduce myself a bit. So, as you can expect, I'm an Android developer, but a part of my interest in mobile applications, I'm also into IoT and embedded. So you could see me hacking around with various hardware at various hackathons across Europe. And besides tech, I'm a great coffee fan. So if you ever need a break from tech discussions, feel free to reach me out in the corridor, LinkedIn, anywhere, for a relaxed convo about roast, brews, like no dependencies attached there, so just feel free. And yeah, let me tell you a story about myself, actually. So back in the university days, I've been often working in some group projects that involved robotics or hardware. And ideas were great at that times, but the budget and resources were quite the opposite. So yeah, we can say we can buy everything online these days, so any kind of electronic components we can imagine, but it costs twice the time and once the money. Why? Because you need time to pick it, to have it delivered, to have it ordered. You need obviously money to buy it, and you need time to connect it, to wire it up, to fix it in place. And like anyone who has ever soldered or doing something like this probably gets the feeling about it. And yeah, like have a look and the example costs of the components we're talking here about for any kind of Raspberries or Arduinos. It just may seem not too much for a well-funded project, but for like students or starting researchers, it can be like costly. And we're not even talking here about shields, amplifiers, connectors, adapters, anything else we can think of that we'll actually need to get it running. So yeah, what held us back often at that days was something like this. It's like nicely put in one phrase, so basically cost and connection complexity of doing some hardware-related projects because of lack of some components available at hand. So, well, there came the idea of mocking, and well, we are all well aware what that is. We've done it many times, but I don't really mean here mocking like just providing some mock data in software. I mean mocking whole components that we could put into the project we're doing, and it will provide us with some real-life data, or it will make some real effect into the physical environment. Yeah, let's think for a while about like one single device that would maybe incorporate versatile features, and yeah, it would be everything nicely put together in a compact form. Yeah, a hint from me, maybe you should look in your pockets. Then yeah, definitely I'm talking about smartphone here, but let's have a look about what it actually offers when we think from the perspective of a hardware project. And let me emphasize here the tab with connectivity, because there are often some high-level services standing behind those, like LTE, GSM, like this kind of stuff. And oh, I'm not even mentioning battery here, which is also something we can take benefit on. Having a look again at those, like totally by accident, these are exactly the components available in almost any modern telephone. It can be just used out of the pocket, assuming we own one, right? So let's think into that. Like let's put it as a part of the system and let it mock some components, right? Now, question for you, actually. Who has ever had an RC toy car? Like, just raise your hands, I want to see it. Nice, so it was definitely fun. But who has ever built one? Okay, but you can imagine. Oh, nice, we have one there. So basically, I believe there are two main motivations when it comes to projects. It's money or it's fun. So it was definitely fun in that example. So I decided to build a remotely controlled vehicle in order, like a proof of concept of the things I'm talking about here, to incorporate an Android device there on board as a part of this system. And yeah, it's the one standing here, actually. And yeah, I didn't really want it to be one of those tiny bots you can buy on the electronic stores. I wanted just something more fancy, but then came the budgeting thing and like thinking about the real stuff. So yeah, we'll see what I came up with. But basically, I decided to build upon some available chassis from an RC toy bought online. So I could benefit from like it being ready available. I obviously got rid of any electronics that were on board and basically used just the mechanics that were there. It allowed me to significantly cut down the cost. However, it also like created a challenge, big one, but I will just maybe mention it later on. And let me spoil you now what I will not cover in this talk, because I bet some of you are just waiting to pop the question afterwards in Q&A session about it. And I'm well aware that Android is not a real-time system. So what I did here was just preparing a simple solution, so an application that can be launched anywhere, I mean on any device. And I didn't try to modify the system itself, because actually it would be super complex, super time lengthy, and I don't really believe it will get us to like satisfying results anyway, because then we would need to flash the system itself, and we would risk obviously breaking the device. The device would need to be compatible with it. Either way, at least it wouldn't be operable in other ways for the time being. And either way, these modifications would need to be heavy, and it wouldn't be a real-time system anyway, so that's not the thing I'm trying to convince you for today. And just a quick word for those of you who are not familiar with the idea of real-time system, because maybe it's more harder thing. Puts it simply, it has to be reliable, and quick in reaction, because it's most often controlling some critical processes that if it fails to control, the consequences can be critical. And also, we don't care here about the versatile solutions and functionality. We just care for it to do the job right and do one job right. There are obviously divisions between various real-time systems, but I'm not going to cover it. It's too lengthy. What will happen if we pick the wrong one for the wrong purpose? But yeah, that's the other thing. And yeah, I wonder how many of you ever worked on electronic projects. But if you did, then you probably encountered this kind of attitude at some point, because it can get really problematic. Yeah, you know what I mean. Really problematic when fixing stuff in place, soldering, fixing out any kind of, tracking down any kind of issues with connection itself. So it's like, I want to jump into coding as fast as possible. But yeah, I mean, one of the things to solve here was that we cannot connect the phone to the hardware directly, because of the lack of appropriate interface, if we mean wired connection. So there was a need for intermediary that would act as a kind of an adapter in this situation. And I decided for it to be an just simple Arduino board that, with the software provided, would translate the communication between hardware and Android device. Worth mentioning here that in my particular design, I decided that the Android device will be holding the primary logic to control the vehicle. Well, I'm an Android developer, so it was easier choice for me. And the Arduino is just providing the functionality of hardware. But with the stuff provided, it could be also the other way, I believe. And yeah, speaking about Arduino. By the way, it's just by doing this particular slide, I noticed how Android and Arduino are spelled super similarly, so it just fits even better. But speaking about the connection, I benefited from Android USB host mode, which basically provides a possibility for simple text communication over serial port, over USB, and is also providing the connected accessory with power from the inbuilt battery, what I mentioned. We can also take benefit from it. But having a look on those, because some of you may have heard of so-called accessory mode on Android, and it seems like it's fitting exactly the same way. Maybe even accessory mode is more widespread in language. Nevertheless, there are primary differences that are pointed out here in those three domains, control, power, compatibility. So basically, in a host mode, it's the Android device controlling the connection. In the accessory mode, it would be the other device controlling the connection. So what's the consequence of that? Also the power delivery. The power would need to flow the other way if we use the other mode. So, and also the compatibility. So the software and hardware would need to be designed a bit different way to handle it. And yeah, I will come back to that actually later. But for me, the choice was the host mode that is more versatile, more easy to actually use. And this is the mode we're actually benefiting from connecting keyboard, mice, or other accessories to modern Android devices. Let me show you the general scheme of the vehicle. It's simplified one, and it focuses on like power circuits basically, but you can actually see two of them, because one is the low power circuit that comes from the phone's battery, and it's powering the Arduino and all the other electronic components. But there's also other one, just to explain that. A high power one from bigger battery, because to drive actually that size of a vehicle, we need a higher power circuit. So there came some challenges about that, because yeah, let me show you some close-ups. How it's wired up. I know it's a bit of dirty work here. A lot of hot glue, right? But it's just a prototype. So basically, when we're having the high power circuit, it has to be separated from the other one using H bridges. Not going too deep into electronic like component stuff, but basically it allows low power circuit to control high power circuit. The challenge I mentioned before was that basically I had no documentation at all. What are the motors, the DC motors used inside? What are the actually bunch of cables sticking out used for? So I needed to have my time with multimeter connected and just playing around with different signals to figure out how to steer the chassis, because it was coming from another RC. It would be so much easier if I bought just it from some robotics store, but it's not the approach I wanted to go through. Having a spotlight on devices that were used. These are the two devices on board of the vehicle. So this is like an Android device, obviously, and the Arduino. There's a cabled connection between them, but there is also like a remote control or tablet with the application that communicates wirelessly to the other Android. So we're benefiting from wireless communication here to just steer it, but also like to get some monitoring data the other way, what I will mention also later. Focusing on this wireless communication, it's a simple stuff. I just used WebSockets over like local area network connections, so there is also like a router involved. You may ask why this way. I mean, I actually tried to do it with Wi-Fi Direct because it would be more direct way, but basically I encountered some differences between how Wi-Fi Direct is implemented in different manufacturers, like by different manufacturers. So there was some troubles with that, and I used back then quite older devices for that purpose. So I just thought, okay, it's not the main thing in the project, so just let's stick to the simplest communication possible. Like spoiling the facts, I mean, it works fine. The latency isn't like super critical, but it's definitely something that can be changed later on. And yeah, let me look like the communication looks like, but oh, wait a second, it's actually something wrong here. Now it's far better, I guess. I mean, yeah, excuse me, that light joke. But yeah, I mean, when it comes to communication, yeah, font is quite a bit small here, but basically there are like a set of classes, set of subclasses of such a network message, and all of them are serializable. So basically, it was the simplest way to do it, to serialize on one device, deserialize on the other one, and to have this kind of communication. But I just like defined all set of possibilities here on my own. So like the system status, like reading from sensors, commands going the other way, so turning, steering, speed, and stuff like that. And when it comes to the wired connection between Android and Arduino on board, well, I benefited from external library to use the USB connection, which benefits from this USB host mode. So I will show you how the setup looks like in general in a moment. But worth mentioning is that on the Arduino side, basically there is no like connection handling logic. Like Arduino is unaware of USB connection happening or not. So there's no such kind of status or, I don't know, broadcast or anything we can receive. So all the logic has to be written by ourselves. It's not like that difficult. Basically, you can see how long is the main like loop of the program. It's basically reading if some data is coming, if it's formatted in an appropriate way. What does it actually mean? What's coming in? So if the data are appropriate, I mean, there is actually a heartbeat mechanism implemented, which I will tell you in a moment. Then everything is fine. If the connection will be broken, then we have to take appropriate action. Yeah, how to use the USB host mode. Like simple steps like here. So basically we're adding a service to the manifest. we're setting some filters for broadcasts that will mean if device is connected, disconnected, like how the status is basically changing, starting service, setting handler, which means here a class that would handle the incoming data appropriately, like parse them, I don't know, do some regex comparison and take appropriate action. Also, obviously, there is some other code that can send messages the other way. But in general, it's that simple. I mean, it's taking the benefit of the library I mentioned, but basically, it's the logic like written here, especially for the purpose I'm talking now about. Like a basic set of commands that can be sent, like they have to be really kept like the same on Arduino, Android, so that the recognition is different. We have different languages. We cannot really like easily share some module between them. Yeah, my main loop on Arduino, because if you're unaware of the concept, like on Arduino, there's no multi-threading or anything, at least not in that one. So basically, everything is kept in one loop, and that executes over and over. Challenge is we cannot really do any delays, any sleeps, and stuff like that, because it would like make the execution longer. So it has to stay reactive to what's happening. But basically, it's like simplified code. Let me be honest with you. It's not like the full, but basically it shows what's the most important. So receiving information, processing information, or sending the other way some readings from a sensor or status of the device. Yeah, again, logic to basically distinguish commands is one big logic condition. So maybe not rocket science there. But yeah, it may seem like easy to just connect, wire up, and nice. But we have to consider many challenges when doing such a thing, because like fail-safes, for example, because many things can go wrong. And I mean, like physically, let's think the cable gets out and we don't really want the vehicle to drive away from us, right? So Arduino doesn't really handle USB connection status. So thus I decided checking the heartbeat would be the easiest way, the most versatile here to actually check if the connection is appropriate between Android and Arduino. So basically I started with just heartbeat message being sent both ways in an interval. Basically, there's an implemented like response to every message that's coming to Arduino, so the other way comes the response, so both parties can treat it as a heartbeat. But then I optimize it in a way that any message can actually be treated as a heartbeat. But if for a prolonged period of time there is no message being sent because we're not doing anything on the controls, there will be explicit heartbeat sent, and yeah, it will just be kept alive. What will happen if it disappears? Well, command all stop, like all engines stop, so we just don't want to get it like damaged, right? And the other fail-safe that's present on the Arduino board itself is like hardware timer that basically counts up if the main loop isn't executing for too long. Because if it is, I mean, it can get something wrong because of like software developer error, right? There can be some infinite loop, there can be some malformed input or any other thing. So this timer will just physically reset the board if the execution time will exceed some value. It's like within 2 seconds here, but in real life we're dealing like with dozens of milliseconds max real execution time of the main loop. So it's like far too much. But this is just like one of the values you can pick there. And most important, after the reset, it will just stop. And hopefully it will handle the new data appropriately, but it's mostly about stopping. Yeah, having a look at the fail-safes on the Android side, but the onboard Android. There's also like the idea of heartbeat exploited here, but two ones, one with the remote controller, one with the hardware. Basically, if the heartbeat with Arduino is failing, then the component should inform the remote controller that something is going wrong and display the information to the user. But on the other hand, if the heartbeat between the remote controller and the onboard Android device is failing, then it should send the command to the Arduino to stop everything, because now we're dealing with the situation that it's a bit distributed across 3 components, because basically hardware as a vehicle isn't unified. It is divided between Android and Arduino. So there are like the failsafes have to be handled on both of those components. When it comes to communication between the two Android devices, as I mentioned, these are some classes. Like currently, I just used another one to carry on the information about the system status, so battery level, I don't know, like Wi-Fi strength, GPS signal, and stuff I can get from the Android system itself. There is also another class handling information that comes from Arduino, so status of, I don't know, light indicators like drive light, like motors and stuff like this, like if there's some features are enabled or disabled. And the other way, there comes like commands about turning, about setting some features on or off, or about driving speed. And yeah, this is a screenshot of the remote controller, basically super simple interface. Yeah, we've all been there, but it displays like the basic information and the video feed from benefiting from the camera on board on the Android, obviously. And yeah, features I got so far, obviously like turning speed control, like some light control, system status, some warning lights, which also indicate if the connection is broken. The thing here is actually the power is delivered via cable, so if the cable between Android and Arduino is broken, we will notice it because of the lack of power, but it can be also the Android side that will fail. I mean, it can hang up, the app can be terminated because we're talking on application level here, not some system modification, so it obviously can be terminated. So then again, it also has to be treated as a connection failure, not as just everything is fine, although the wired connection is like actually happening successfully here. Yeah, when it comes to video streaming, I basically didn't really focus on that part because we know that video streaming can be a topic very complex and very long to implement it well without the latency and delays. So basically, I just benefited from another application that will do the streaming, and I'm just like receiving the stream on the other hand, and that's fine. But obviously, it can be something to be implemented like in our solution as well. And yeah, let me show you how it's actually getting about like in some real life scenario, because it really turned out to be super low agility with that vehicle. So the turning angle is so big it's hard to operate indoors anywhere. But obviously there could be some additional safety features implemented, like using, yeah, that is how the application looks on board. Like it's super boring, just displays some basic stuff. Some additional safety features, so like gyroscope to detect if we're not trying to drive up the hill that is too steep and we could burn the DC motors, for example, or just the vehicle could turn over, or using the distance sensor also as automatic collision sensor in order to avoid hitting some obstacles that are in the front of, because it's just like actually displaying the value. I mean, the ideas are basically infinite, but the thing is that it's actually easy to damage physically. You can see how shaky it basically is. So that's why the fail-safes I talked about are needed, and that's why some additional safety features would be also like necessary, but recommended to just keep it all in shape. Yeah, I think if we have time in the end, I can also like do some close-ups live here, or obviously after the talk, you can reach me out and we can have a look. We can fire it up and try to use the vehicle itself. But yeah, as for now, it looks like this. Obviously, it's like super prototype version now. It's early phase of what I'm doing here, but it's just reached the point where it's a proof of concept. It's basically working in a scenario that's not that easy. I mean, we have some vehicle basically driving, right? So it needs to respond quite quickly and do something. And it's obviously fun, right? Just to mention, it wasn't the easiest part to get it today here because I was traveling by plane. So basically, I caught attention of any security guard, obviously, what I'm actually taking here, and I had to put it into parts and then put it back together in hotels. So yeah, let's hope it works. We'll see. Yeah, wrapping up, I haven't seen actually this particular approach in other projects when I was looking for it. And it will be so much of a help for me and my friends when back in the days I mentioned in studies, when we were working on similar projects, to be able to benefit of something like this, because building it from scratch took a long time. But if there was a library that we could use, basically adapting, obviously, because all the inputs, outputs would be different, so it needs to just be put out simply to be modifiable, right, for anyone that uses it and actually has idea what he's doing. But it would be a benefit. So basically, if it goes right, if I manage to wrap it up nicely, and I don't really get caught by any other side projects, but by that time, I'm planning to publish it as an open source for the others to build upon it or to benefit from it. Like we can see where it can actually go. Yeah, but in general, feel free to reach me out if you'd like to cooperate on that or something. Like there are many next steps, like improvements of graphical user interface, notifications, blah blah blah. But basically, to provide also generic support for some other sensors or effectors that are out there and are quite often used. It can be on some abstraction level. It doesn't have to be particular model of electronic sensor, but just abstraction level to provide support for that kind of things. Not even mentioning all kind of issues and problems that I'm already aware of and that need to be fixed in order for it to work nicely and really exit that super prototype, let me say super prototype phase. Yeah, that's pretty much it. So feel free to reach me out. But I'm really curious about your questions here. And if there are not too many, we can just showcase something maybe closer here and stuff like this. So yeah, I'm actually good with time here. So yeah.
What's the top speed?
What's the what?
Top speed of the model.
Actually, didn't measure it. I was a bit afraid of using the top speed, but it's quite on flat surface. It is quite speedy. We can check it out after the talk, definitely. But yeah, it's one of those bigger RCs, right? So it is there. Please. Mm-hmm. Yeah, it would be a choice also. And I also actually worked a while ago in other project on interfacing Raspberry with Android. It was a bit something else, but putting it simply, Arduinos are simpler and lower cost also. So if I just wanted it to be act as an intermediary between hardware and Android, so it was just the simplest solution actually I could think of than having Raspberry with whole system and with this versatility it offers, obviously, but also it would go too wide. So that's here now is the simplest thing. But if we were to put the most of the weight of controlling on the Raspberry, for example, then it would be better choice. I mean, maybe better choice than Arduino. But obviously, we would have to consider these real-time situations also. But yeah, it's a valid option. It just didn't fit the scheme here. Okay, so any other questions or what you're curious about?
How durable is it if doing a jump?
Okay. Well, truth to be said, I had few occasions to witness it falling down. Maybe it wasn't a jump as per se. Well, it did. It did obviously survive that, but hard to answer. Definitely, I would rather put it on the fragile side of scale than on a really robust one, right? But basically, it's also because it doesn't really contain a hull, any kind of upper part, right? Everything is taken apart, so all the internals are visible. If we did it, yeah, it could be, but that's just a hardware, physical stuff, so I wasn't really concerned about it. Okay. So, oh yeah, last one. Or maybe not last one. But
I just wonder, maybe I missed it, but is it possible to like other repo for the code that's related to like Arduino part and Arduino part? Like, is it possible to like work with it together and then use it for other vehicles or similar coded projects?
Definitely, but maybe you could just narrow down the question because I didn't really get what's the part here.
I wonder if it's possible to develop into some kind of framework that everybody could use for.
I'm planning to just publish it. I obviously have it like on a repo, but it's just not published yet. So as in like open source kind of initiative, maybe I'll get in cooperation with someone to develop it further. Maybe some of you, who knows. But and to publish it to be like enable others to use it. However, there will be like a phase of getting some kind of feedback also, because to define how it should really look like for the others to be easy to use, because there definitely is going to be parts that everyone would need to modify on his own, exactly, especially when it comes to hardware interfacing. But in order just to be like reliable and easy to modify, then definitely, I cannot really put any kind of time frame here, because it's like my project, like side thing as an individual. But I hope it will happen sometime. Okay, so thanks a lot for attention then, and like feel free to come by and we can talk also after the talk.